This lesson is an introduction to organic chemistry, bonding behavior. Organic chemistry is the study of carbon-based compounds. And carbon likes to form 4 bonds. But it's important to understand how other elements bond. So we're going to start at group 1, hydrogen. Group 1 elements like to form 1 bond. They have 1 valence electron, and they share their valence electron with another element, forming a bond, and its outer valence fills up with those 2 shared electrons. We're going to skip over to group 14. We're dealing primarily with elements that are involved in organic chemistry. So group 14. Group 14, we have carbon. And as we said, carbon likes to form 4 bonds. And another element in group 14 is silicon. Silicon also likes to form 4 covalent bonds. So it has 4 valence electrons, and it shares those valence electrons with other elements, filling up its outer valence to an octet, and therefore it will end up with 8 valence electrons. So both carbon and silicon prefer 4 bonds. The next, we will look at group 15. Group 15, we have nitrogen and phosphorus. Both nitrogen and phosphorus prefer 3 bonds. They have 5 valence electrons, and they will form 3 bonds to fill out their outer valence. So they start with 5, and they add 3 shared electrons, and therefore ultimately they end up filling up their outer valence, and we call this the octet rule. Not all of these elements follow the octet rule, but nitrogen and phosphorus tend to prefer a filled valence with 8 outer electrons. The next is group 16. Group 16 has 6 outer electrons, and that would be oxygen and sulfur. So both oxygen and sulfur have 6 valence electrons, so they like to form 2 bonds. And 2 additional shared electrons plus the 6 present outer valence electrons fills up their octet. Finally, we'll talk about the halogens. Halogens are group 17. So within group 17, we have fluorine, chlorine, bromine, and iodine. So all these elements have 7 valence electrons. They need 1 additional electron to fill out their outer valence, so they tend to form 1 covalent bond. So let's look at some examples of each of these groups so we can get an idea of how they behave. So the first one, we'll start with hydrogen. So the most common example we think about is H2O. So if we have a hydrogen And we have another hydrogen bonding to oxygen. So each hydrogen provides one electron, and the oxygen provides an electron for those bonds. And then we have two lone pair electrons on the oxygen. So there we have H2O. Oxygen has a completed octet, and hydrogen, it only requires two valence electrons to fill its outer valence because it's a very small atom. So it has a completed outer valence. Next, let's look at carbon. Good example of a carbon compound would be methane. So methane is CH4. So we have central carbon atom with 4 hydrogen. So the hydrogen provide 1 electron each, and the carbon provides 1 electron for each hydrogen. So there we have a completed octet in the outer valence of the carbon, and the hydrogens, the outer valence, have 2 electrons. Silicon dioxide. Silicon dioxide is SiO2. So we have the silicon. Now, silicon will create double bonds with oxygen. So in each double bond, we have 4 electrons. And then the oxygen will have 2 lone pairs. So there we have 8 electrons in the outer valence of silicon. Silicon had 4 valence electrons and added 4 shared electrons for 2 double bonds. There we have silicon dioxide. For nitrogen, common nitrogen organic element would be ammonium. So ammonium is NH3. So we have nitrogen, and we have 3 hydrogens. So each hydrogen provides 1 electron, and the nitrogen provides 5 electrons. So we have one shared electron for each hydrogen, and then we have a lone pair on the nitrogen. So that is ammonium, or NH3. Another example would be phosphine. So phosphine is pH3. So we have the central phosphorus providing 1 electron for each hydrogen, and then we have 3 hydrogens, each one providing an electron, and then we have a lone pair on the phosphorus, completing the octet. So there we have pH3, or phosphine. Let's look at our group 16. So in group 16, we'll start with CO2. So CO2 would have a central carbon, and then The carbon forms double bonds with oxygen. And so the oxygen, we know it has the oxygen is providing 6 electrons for each, and the carbon is providing 4 electrons. So we have completed valence for carbon. We have 8 outer electrons, and each oxygen has 8 outer electrons. So for sulfur, let's draw the Lewis structure of sulfur difluoride. So we start with the central atom of sulfur. And we have bonding electrons from sulfur. And then we will add our fluoride atoms. Now, sulfur, we'll add the bonding electrons. Now, sulfur is in group 16, so it has 6 valence electrons. So we will add 4 more. So now we have 4, 5, 6 sulfur valence electrons, and we have 2 covalent bonded fluorine electrons. So our valence for sulfur satisfies the octet rule. And for fluorine, as we said, fluorine is in group 17, so it has 7 valence electrons. So we'll switch colors. And one, 2, 3, 4, 5, 6. So now fluorine has 8 valence electrons, and sulfur has 8 valence electrons, and that is sulfur difluoride. Finally, in the halogen group, we have fluorine, chlorine, bromine, and iodine. An example of fluorine would be hydrofluoric acid. So start with the fluorine. So the fluorine, it provides 7 electrons. So there we have 6, and then we have the shared electron, and then hydrogen provides an additional electron. So hydrogen, the valence is filled, and fluorine, the valence is filled with 8 electrons. Chlorine, an example would be hypochlorite or ClO minus. So there we have Cl. So we have 3 lone pairs and a shared electron, and then we would have our oxygen. And we have 1 extra electron, so the oxygen, we would have a minus symbol above it. The next, for bromine, hydrogen bromide. Hydrogen bromide, we would start with the Br. We have 7 outer electrons, and then the hydrogen would provide an additional electron, and thus we have completed valences. Next would be iodine monobromide. So for iodine monobromide, we'll begin with the bromine. So it's a halogen, so 7 outer electrons, and iodine is also a halogen. So 1, 2, 3, 4, 5, 6, 7. And thus we have 2 halogens forming iodine monobromide, and we have completed valences. So that's the end of the organic chemistry coverage of basic bonding behavior. Thank you.